Hey guys, welcome to the video tutorial dealing with single and double slit type problems. Um, on the AP test, generally you come across these problems in the free response section. There aren't too many multiple choice options for single and double slit, but we'll go over those types of questions that you'll see. But the majority of the questions that you see deal with oh, that's got away from me. Deal with free response type stuff. And so let's start with some equations that you'll need to know. First, you'll need to know this right here, m lambda L over D. Now, what that equation is it deals with the double slit. And so you'll have a distance between the centers of your slits, D. You've got the wavelength of the light coming in. And then your viewing screen, in other words, where the interference pattern is hitting the wall, or it could be a screen or whatever, is a length L away. And so some possible options that they could do is they could ask you to describe, okay, what happens when you move your viewing screen further away? In other words, you increase L. Well, this xm, what that is, if you were to graph the intensity, then we have a peak intensity in this center, in other words, right here, and then they kind of radiate out. Now, the key here is if you're asked to graph this type of problem, this distance right here is xm, and this is the first constructive interference to take place. So this would be where m equals 1, this would be m equals 2, and then here is m equals -1, and so on and so forth, because right here x equals 0. And so what you're doing is you're calculating the distance between the successive constructive interferences. Now, to graph this, halfway between is where you put your destructive interference. And again, this is for a double slit. So what they could ask is, okay, if I move my viewing screen further away, what happens to my interference pattern? Well, if you increase L, then that means that you increase the distance between these constructive interferences. They could ask you what happens if you shorten your wavelength or increase your wavelength. So a possible question is, what happens if I change the color of light? If I go from, violet, which is 400 nanometers, and I go up to red, which is around 750 nanometers. And so, obviously, if you increase the wavelength, then you increase the distance between these constructive interferences as well. So, it's not only important to know the equation and how to calculate things, but how to describe what happens qualitatively. And so one option that they could do is they could say, okay, we're starting in air, and then we go to the light moves through a fluid, and it has an index of refraction higher than air. Well, if you're changing mediums, what doesn't change is the frequency, but what does change is the velocity. And if the velocity changes, then so must the wavelength. Now, the equation for frequency is my velocity divided by my wavelength. And so if you decrease the velocity, then you must decrease the wavelength also in order to keep f the same. So that's a possible double slit type problem. Again, that's the main equation that you need to know. Another equation that is useful to know is how we talked about, or not an equation really, but how we talked about single slits and what their graph looked like. And so if we had a single slit, then really the only thing that happens is we have constructive interference in the middle. We have, humps that aren't even worth considering out here, but the main thing about a single slit is that you have one peak in the center of your graph. And so that's the main difference between these two graphs, is that when you have a double slit, you have more constructive interference as opposed to a single slit. Now, we talked about an equation that involved theta of the wavelength, d, and m. So I'm going to let you guys go back and look through your notes and find that equation, because that's a possible multiple choice type question. Is they could tell you, okay, I've got interference occurring at 6 degrees or something, or 30 degrees, and they'll want to know how wide is my slit. And so find that equation that we talked about and use that for that type of problem. Again, it relates the wavelength to the distance of my slit. And so really that's the types of problems that you can expect with a single and double slit, the subject material of those problems. Again, main thing to do with those is go over the free responses that we practice, and then really know how to work this formula and describe it, and then also know how to find wavelength and how wavelength could change if you change the medium of what your light passes through.